So on Monday, you guys will get back Chapter 8 and Chapter 10. But for today, it is the 18th. We're going to try to get through 9-2 and give you guys time to start on that homework assignment. So, you guys probably don't have your 9-2 notes. Do we want to be really efficient and just pass on all the rest of the notes?
Yeah.
Okay, let's do it. Can I get some help?
I would say this, don't give all of them to Brian.
He's gonna lose
You
them.
have
I
9-2.
wouldn't lose any of them.
You have 9-3.
Okay, this is today's notes. Here's
9-4.
tomorrow. Monday's notes.
I don't know if anyone's there. It's honestly all lost and found. Yeah. Like, sadly enough, I don't know whose hat, I don't know whose jacket. That book has been here for days.
How many extra copies?
A couple, but like, yeah, we're digging it today.
Wait, where's Megan? Is Megan here? No.
So one of those sets will be for Megan. There's 5. If I was you, I would probably staple these together. There's 5, there's 5, there's 5, and there's 5. I forget how many I told the copy center to send me, but I'm sure I have a plenty of extras.
Here are the extras.
What do you have? 4? 3? I have them in my binder already, thank you.
How did you lose your notes?
Where's my eraser?
Oh, Carmen.
Brian.
Me?
You gave it to me. I didn't know that.
Or where?
How are you?
Oh, I'm doing well. It's the weekend. I didn't know what you asked. All right, so let's dive in. So what's the main difference between a prism and a pyramid? Because they're very similar, actually.
Yes.
We're on 9-2.
I know, I don't have 9.
Oh, then that's my bad. You must have been standing up or something. So the difference between pyramids and prisms. Michelle, what do you think?
Prisms have 2 bases and pyramids have 1.
Yeah, prisms have 2 bases where pyramids only have 1. So now when we use that base, we don't have to double it. And what about the lateral area? Those lateral faces. Yeah, you got to compare back to what the prism had versus what we have now. Brian?
Would it be the same, like, algorithm or whatever, equation, but just divided by 2?
Why?
Because it's triangles.
Yeah, whereas prisms had all faces that were
Squares.
rectangles.
I was giving you that.
Clear.
Some have squares. Pyramids have all faces that are triangles. So the only thing we're doing here is essentially cutting everything in half. Because instead of 2 bases, we have 1. Instead of the whole lateral area being perimeter times height, it's now perimeter times slant height, which is still the height of those shapes. But that perimeter times slant height then has to be divided by 2 or multiplied by half because they're triangles. Any questions about how that relates back to our prism
Why
formula?
is this that?
Because I can't use vertical height because that won't actually give me the area of the face. If I use vertical height here, that is not the height of the triangle. That's the height of the pyramid. Makes sense? So slant height is the height down the edge of the pyramid, which will be the same every way we go around. Well, it won't always be the same, but the formula lets it work itself out. Yeah?
Does it have to? Do the triangles have to be congruent?
No.
So, like, you can have a right pyramid.
It's weird, I know, but like all you do is take the perimeter, and so and this, if you want to play in GeoGebra, this is really cool to see. But in GeoGebra, you can set up a 3D pyramid and then drag the top point, because what happens is one of the faces gets smaller while the other one gets bigger, and they kind of compensate for each other. Which is the same thing with volume. Volume can be preserved as long as I don't pull up. I just move it around. It can change how it looks, but it still preserves how much space there is on the faces and on the inside. So this is our, well, and we really only work with regular pyramids right now. Once we get into, like, you can get some really funky pyramids that this won't work. Like if you had, like, let's say the top point was way out here and it went like this sort of thing. You know what I mean? Like that's really poorly drawn. But if they stretch it way over the side, that won't really work like we deal with. But this is for regular
Why wouldn't it work?
pyramids. We just have to change our formula. We'd have to break up the lateral faces and look at each one individually.
Alright.
And I'm not actually certain that it wouldn't work. I just am not confident to say it would work. Like maybe on Monday we'll just play with some of these. Maybe I'll try to create something in GeoGebra that you guys can start with a pyramid and then drag things around and see what happens. Carmen?
Is there any reason we would need like the height of the pyramid?
Yeah, for volume.
Or well, okay, but other like for surface area.
No. So, and then when we go to find the height, if you see this, the altitude that's dropped down, you can make a right triangle using the slant height and the altitude and half the distance across your base, and then you can solve for either, if you're given the altitude, you could solve for the slant, or if you're given the slant, you could solve for the altitude.
The formulas wouldn't work if it's not regular because the triangles would not have the same slant.
See, but I wonder if it would average out, because if one got smaller and one got bigger, that's what I'm curious about.
So that one would get
And that's where mathematicians just play with stuff.
those two would stay the same, and that one would get bigger. So maybe.
Like if I drag this to over here instead, see
I
that's
think
what
of
I'm.
it like a right pyramid because that's easy.
Yeah,
to figure
like
out.
so if this was here,
So if the slant height of that triangle was the height of the pyramid.
yeah, and that's like I don't know. Let's play with it. Well, I'll try to create something over the weekend.
Okay.
For a regular cone, and this is what's weird to visualize. What is the lateral area of a regular cone? Like what sort of shape is it? Caleb?
Would it just be that little like cone? I mean, both like would it be like the
Cone is a
without the base?
three-dimensional object.
Would it be like the cone without the base?
Yes, but imagine taking that cone and laying it flat.
Oh, it'd be a rectangle. Wait, no, was it?
Brian?
It'd be a curved rectangle.
Yeah.
Wouldn't it be like a half donut?
Now, donut's still 3D.
Okay.
So if we're talking about area, we got to switch to 2D.
Well, what's the name of a 2D torus?
You mean like a disc, like a portion of a disc,
Well,
where it's like open in the center?
Yeah.
Yeah, I normally we just call those like, I don't know if disc is the technical word, but still not quite. You're getting closer, but not quite. Ethan?
Semicircle.
Closer, or
A circle.
it's just a portion of a circle. How much of the circle is determined by the size of the cone. So our formula here for lateral area becomes half of 2 pi times the radius. So it is all like, that makes it seem like it is a perfect half circle. This formula works out, but I believe it's not quite. Notice how it's not exactly the semicircle. It's almost there. Not quite. So surface area then, we just take our lateral area, which we end up using pi r L. L is our slant height, but what does L really represent there? The slant height, the height from the base to the top of it, when I blow it up into 2 dimensions, what does that slant height really become? The radius, right? So when I lay it flat, I really have a circle and a portion of a circle, which we can just go ahead and call semicircle because it's pretty much half. So let's try this out. With this regular pyramid, we have base edges of 6, slant height of 9, and a distance to center of 3 radical 3. Anyone know what first step we would take for this? Because there's multiple ways we can work towards solving it. You can start with the base, or you can start with lateral area. Carmen?
Well, if we started with lateral area, I guess we could do that first.
Sure.
We would like count the number of sides. So there's 6 sides, and we multiply that by 6.
Yeah, so our perimeter is going to be the 6 times the 6. Gives me 36. Michelle?
Instead of doing 6 sides, because you would have to do for the formula, the triangles, you have to divide by half. So you can
Yeah, so, and that's all technique. That's all just how you decide to do the technique. I'm going to work pretty rigid right now just to not confuse anybody, especially Megan. Hopefully you end up watching this at home. I'm waving to the camera. Oh, Ethan turns around. So, she probably won't. It's okay. Caleb?
Well, I was going to say you can also activate the area of the base, and it'd be pretty easy with how they've set it up because, you know, well, I mean, it gets into a little bit of math, but you know, it's a 30, 60, 90.
Ah, so we know a 30, 60, 90 because this inner angle right here is going to be 60 because it's a hexagon.
And then you can also, well, it's also an equal, like if you take one chunk, it's also an equilateral triangle.
This would also be 60, and so would that. So since it's equilateral,
What?
I don't know, you just said it's equilateral. Where are you going with that?
I just want to point that out, but I was going to say that you can just solve for the, since you know the height of the triangle, you
Yeah.
know the base length, you could just solve for the area of that and then multiply by 6.
Because they've already given this to me, we don't really care about the angle measures. Like we could, and we will in certain problems, but this is an easier one. So, when we start solving base, I agree with you though, Caleb. They've given me the base of 6, the height of 3, radical 3. I know that half of 6 is 3, so really I end up with 9 rad 3, but that's only one portion of the base. So this is 1/6 of the base. It's just this triangle. So then, to find the base, we take the whole thing and multiply it by 6.
54 rad.
We get 54 rad 3.
Also, 93.53.
Did you get decimal answer or what?
I got 108.
Is that a like
No,
you're
the
not in
decimal,
a,
I forgot to half it.
No, I have to.
no, so half of 6 is 3. 3 times 3 gives me 9. 9 rad 3.
I might have done something really.
You probably forgot to half it because 108 is exactly double of 54.
Oh, you got 108 radical 3?
I just 108.
Let me look at your math.
Three
That's why I like
rad
the calculator.
I like. I don't know if I do with that.
Wait, what? So we switched from, so the 36 that you're using, that doesn't have to do with the base. That 36 has to do with the perimeter. So you, I think, are merging two different problems.
But like I was.
That 6 doesn't matter. Those edges of the triangle, because we need base and height of triangle. So we use the 6 and the 3 rad 3. You gotta write down your work, dude. That's what I said.
No, I just like forgot.
No, you need to write down your work. I know, like, yeah, you forgot a couple things because you're not writing things down. All right, bring it back. So we're still over here. This is working towards our lateral area. So we got our perimeter. From there, Straveler.
You would multiply that by 9,
Yeah, do that.
I think. You guys scared me.
That gives me.
And then that gives you 324, and then you divide that by 2, which is 162. And then you would merge that with 54 rad 3. Yes, fuse.
And you get, yeah, and then you get plus 54.
Does it say rad form or decimal?
It
It doesn't.
That's
It doesn't. Then
I wrote it
so we
decimal.
get for total surface area.
255.53.
Sorry, was it 255? And inches squared. Question. Right?
Why do teachers care so much about naked numbers?
Because when you get out in the real working world, somebody not putting a label in like a plan or a project or something can screw everything up and waste a lot of time, and time is money. So the more detail you give, the more likely you are to keep your job. So if you turn in a report that's missing labels and units and information, you could easily get fired over the fact that people get tired of incompetence. Really, like, if I'm just going to be direct about it, that's what it goes down to. Calvin?
As an example, I was watching an episode of a TV show, and at this school, there's this locker. They messed up the units, and one of the lockers is like 3 times as big as all the others.
And like construction people, when you hand a construction guy the plan, he's going off that plan to a T because they think that's what you want. So if you have something wrong in your plan, you put feet instead of meters or you put feet instead of inches, they're building what you told them to build by those dimensions. Which, yeah, funny things like that end up happening. Or there's a handicap ramp that's sloped like this because they swapped their rise and run. They wanted it to be sloped like this, but they accidentally flipped their slope and yeah, I've seen crap like that where you want a wheelchair to go up this ramp?
Okay.
Don't think so.
Well, then, creative.
Michelle? Yeah. So, can we move on?
Yeah.
You sounded like
Mr.
Mr.
Hudson.
there for a second.
Mr. Hudson.
What?
In Creative Start, everybody except Brian, Kate, and I made house plans, and we have to model them in Blender. This one group made a single block on the science paper that has the grid on it, 5 feet, and so the hallway was like 300 feet long.
And then they had their
It's like Bill Gates' house or
they
something.
had their TV was, I think it was 40 feet long, and they had their kitchen 20 feet long.
And they had 2 doors to a couch.
And then they didn't have a door to the.
So, this is what I'm talking about.
Really great how to get, open the
It was
door.
really
And I want to do more bringing people in. Randy's been really busy, but my buddy Randy, who I always talk about, who's an architect, he's out today doing field measurements. So they take laser devices and they field measure the place they're going to build things, so then they can make the plans based off those dimensions that they know they can work within. So let's move on. Let's all solve this together so we don't end up in different places using different numbers. Do we want to solve lateral area or base first? It doesn't matter which. Michelle, you've been waiting very patiently.
Let's go with base.
Let's go with base. So we see it's a square-based pyramid. So to find that base area, we're going to do
5 times 5.
5 squared will give me 25 meters squared for that base area. Then what do we want to do?
Then, well, that's your base. So then you can get this, the lateral area by doing the slant height times 5, and then half of that times 4.
Yeah, so the first thing I'm actually going to do to list this out, if you just want to think through this when you're solving lateral area. First, how many faces? 4. What is each of the faces? A triangle, so it's half of its base times height. Then the triangle base is 5, and the triangle height is 3. So if you want to just be able to put it all in one expression, number of faces, area of each face. And then you can half whatever you want, because 5 times 3 is going to give me 15. I don't want to half that because it's messy. So forget that. I'm going to half my 4 based on commutative and, based on associative property. And I get 2 times 15, which gives me the lateral area is 30.
Meters squared.
Which then makes my total surface area 55 meters squared. There's not that much work that needs written if you're careful with your details. Questions? So, first thing here is number of faces, then area of each face. It was the number / pound symbol way before it was ever a hashtag.
We're in hashtag world now.
Dear Lord, help us.
Hashtag blessed.
I'm still resisting, and I don't have an Instagram. So
Really?
What?
people
I
put,
would pay.
I don't have an Instagram.
Really?
How much on
I
my
would turn on
return?
post notifications.
I have 5 Instagrams.
You can post math equations.
that's absurd.
Mr. Hudson,
Yeah,
you can post
okay,
it
but
just
I
on your
needed the
Facebook,
backup
like
one.
math
When it
That's
was
pretty much
being
all I do.
people
And then
might
Okay.
post it.
ask
Sorry,
them, give us
let's get through the notes so then we can just chat.
Yeah, we
because
would all
the-
follow you, so you would look really good because you have a lot of followers.
yeah, except that'd probably look weird to people that don't know that I'm a teacher. Why are all these 13-year-olds following
You
me?
have like
teacher.
15
I'm not creepy.
followers. teacher.
We
I'm
can
not.
announce it at 4 and follow Mr. Hudson's Instagram.
Yes, we do that.
Instagram.
Wait, I have a
Can-
question.
Can we move on? I want to give you guys time to work on your homework.
Okay,
Look, only maybe if we get through this lesson.
Okay.
I'm not like vehemently opposed. I just like Mrs. Cullinan made me make a Twitter. Like literally one day she was like, "Get out your phone, download." No, I haven't tweeted in like 2 months.
Why?
I use it to follow people. Like I use my Twitter to find stuff. Lots of great educators are on Twitter posting articles and blog posts and things like that. Like Dr. Bowers' blog is really good. He writes great stuff. So, the pyramid of whatever word I can't say in Rome, Italy is, and I'm pretty sure this is darn close to the real dimensions. It is 30 meters wide, which is almost a football field, guys. A football field's under 100 meters because a meter's longer than a yard. So that's almost a football field in width and length. This is huge. What is the surface area? Now this pyramid technically actually goes up with like stair steps, but we're going to ignore that and just say what would be the surface area if it was like the Egyptian pyramids with the smooth sides. Calvin, walk me through. Lateral area, because we wouldn't care about the ground because it's sitting on the ground. So let's say like this sort of application, since you guys are always wondering like why would we do this? If they were trying to restore a pyramid or something like this, and they were trying to use a certain chemical or a certain whatever, they would need to know the surface area to know how much to buy, or lateral area. Sorry.
Couldn't they just have like an estimated idea and just buy more?
But they would need to do some math to even have a decent estimate. Because like this pyramid's in the mid, like it's not close to things, so you'd want to like take in what you need and not a bunch of extra stuff. So like when you're doing home projects, that's a much smaller scale, but calculate how much I need before I go to Home Depot. I don't want to make another trip if I run out. I don't want to buy a bunch of stuff I don't need. So to calculate our lateral area here, I'm going to have to start paying Michelle. Can anybody else help me?
Ooh,
Mr. Walker.
yay. So, start out with the lateral area. You can set up that little, well, you can start to set up that equation that we had. So, you can have 4, because we know there's 4 faces. 4 times 1/2 times 30, and then you have to find the, whatever it is, the slant height. But you can do that because, okay, this is something I wanted to clear up. Can we assume that the line going straight down, that like the little, does that form like a,
It's a writing.
right angle?
There is a right angle there.
Okay, so we can assume
Yeah.
that half
And
of that is half of the
Dropped altitudes, we always like, an altitude is perpendicular to the base.
Okay, so then we
Yeah.
can assume that since it's half of 30, we know we can use Pythagorean.
Yep.
I forget how to say
Or-
it.
Theorem.
There you go, that word, and you can find out the slant
Whoa.
height. And that would be, I didn't do it yet, but I can do it in a second.
So the base edge of my triangle is 15. The other leg of my triangle is 36.4. If we square and sum and then square root, Brian?
39.3695, blah, blah, blah.
37.
Really, I got 12.2.
Oh, you saw? Yeah, you
You subtract,
not a distribution.
Good.
So then I can either half my 4 or half my 30. I'd rather half my 4. So I get 2 times, or quadruple your half. So what do we get when we put these all together?
2,362.2.
Holy crap.
Brian's the nearest square meter.
That is
2,362. I thought it said 10.
So let's say that they were buying something like a chemical or something like that that covers so many square meters per container.
That's a lot.
This would let them know how many containers they would need to buy.
So just
And you would
downstate.
buy a little extra. So like my buddy Dave, who just bought a house and he's like redoing his floors, his house is 1,900 square feet. You wouldn't order 1,900 square feet of flooring because you make cuts, you have excess. So based on the minimum order that they would have to make, they ended up ordering 2,300 square feet. Because that was like, but they know, like I was over there last night helping him work and I was like, dude, go try to cut this. And he's like, what if I screw up? And I said, you ordered 400 extra square feet. You can screw up. It's sort of that whole like mastery process. He's not at master yet, but
Wait,
he.
how would they clean this? Would they just like pour it on top, or they like?
They have certain chemicals that literally like will seal the stone. So the issue with old structures like that is the stone will start to deteriorate because as moisture gets in there and then it changes temperature, water changes size, like pretty dramatically on like,
kind of cracks.
yeah. So it makes these minute cracks. So they'll put chemicals on it that actually stop the water from being able to seep in, and this chemical kind of like seals it, and that chemical won't change size. So it's, if you've ever, like a really nice patio, like brick patio or whatever, will have a chemical put on top of it that seals the
My
stone.
neighbor has one of that. He was spraying it on.
Yeah. And they normally do like a light mist sort of thing, and it just soaks in.
And then
Wait, but how
is it the one
would,
that makes it kind of like shiny?
Yeah, like a little
wait,
bit.
but how would they get the entire pyramid?
Like literally, they'd probably set up scaffolds.
A ladder.
These are big restoration projects. They had a big restoration project on the Leaning Tower of Pisa a while
I
ago.
went there.
Yeah?
Wait, yeah, didn't they like lean it
What's
back
up? Oh, pop filter. Thanks, man. Oh, just so you know, the guys that borrowed this yesterday, I think somebody stepped on the cord. It's just a USB cord, so we could always get a different one. But it just like is angled down now. Yeah. Told him to be careful. All right, so just the lateral
Good
area.
morning, Jeremiah Hone. Please come to the office. Jeremiah Hone to the office, please. Thank you.
1,309 feet squared. If we write out the work for that, it'd be how many faces? 6 times the area of each face, obviously half. What's the base edge?
Base edge.
Yeah.
36.
36. And your slant height?
I got it.
I just want to make sure we all have the same slant height. You probably did the Pythagoras or the Pythagorean.
I did. I'm just trying to figure out. Yeah.
So here's the cool thing about hexagons. They make equilateral triangles, right? So if I come into here and I see that this edge is 36 and that makes an equilateral triangle, Lynn, give me your eyes for a second. This, and I don't know if this is what you inferred, that edge is going to be the same, this edge is 36. So any of these blue lines are all 36. So the height of the base triangle, this guy right here, or this guy right there, or that guy right there, like any of those, really are in an isosceles triangle where this is 36, this is 36, this would be 18, this would be 18, and these are 60. So we could trig or Pythagorean theorem or special right triangle. So on a 30, 60, 90, how's the long side compared to the hypotenuse?
Radical 3.
Times radical 3.
No, that's compared to the short
Yeah.
That's similar to the
That's
short
what I was
bow.
saying.
What do we compare the long?
So you divide by 2 from the hypotenuse. You get the short leg.
You know the short
You know, the short leg's 18.
But he's saying from the
Okay,
hypotenuse.
which do I, my red line here, which do I relate it to?
The short S.
So 30, 60. 30, 60. What's the rule that we remember since we're using 30 and 60? Shell?
You multiply by root 3. So, well, you would take 18, which is the short leg, and you multiply it by root 3 for the long leg.
So my red line here.
Yes, but you were relating it to hypotenuse. That's what he
And
said.
then why are we related to the hypotenuse?
I set trap doors.
Yeah.
No, we
The only fun I get to have is seeing if people are paying attention.
And then
Well,
we'll-
not the only
and then we'll
fun.
start yelling at or
Well,
creating
yeah.
an Instagram, that could be fun.
When?
I changed my mind.
You think you changed your mind?
Yeah, I think I did that wrong.
So our height of our base triangles we get is 18 root 3.
Wait,
So-
wait, what? They told us that number. Oh my god.
Oh, is my page not far enough
Yeah.
over? Oh my gosh.
That's
Guys,
not-
you
that's
could
what
have
I was
told me that.
saying.
Somebody could have told. Well, okay, so it's still 18 root 3. That doesn't change what it is.
Wait, but
Fix it.
wait,
Wait,
that's
that's
not
not
the
the
slant
slant
height.
height.
No, that isn't the slant.
That's not the slant height though.
We're still working on the base.
doing?
I don't know either. You guys have me all 9 different directions. Michelle, help me.
The answer that Lynn had was the slant
Yeah,
So,
sorry.
And then if you take the square root of the answer that Lynn had, that's
6.4.
So where I was trying to use the 18 root 3, I'll explain where my head was 9 different directions.
Right.
The 18 root 3 is going to be a leg of your right triangle. The altitude is 42 given to us. The slant height is what we need to solve using our 18 root 3 and our 42. So we got to use Pythagorean Theorem because we don't know anything about the pitch of our edges here.
the slant height is 36.186052711.
Why is that
So,
more than
if-
more than 42?
Yeah, it has to be.
Yeah, I think you did it wrong. Did you subtract instead of add?
Yeah, that's mine too.
I got
No, I didn't
52.3.
subtract it to add.
I got
I have to get a calculator. Okay, so people, we do 42 squared plus 18 radical 3 squared. Make sure you're typing that into your calculator right, because that could get you in trouble.
Yeah, put 18 radical 3
In parentheses and then square it. Square root that answer.
Yeah, I got 42.6380.
I got 42.6 as well.
Keep India rapping.
That's a really skinny triangle.
So the pitch of this is really steep, is what that tells you, because the altitude is so close to your hypotenuse. If, like I was looking at it, they hadn't given you the distance in here, we'd have to derive it using either special right triangles, trig, or Pythagorean. Now I can plug in the 42.638. And we solve out. Do we have an answer we agree on yet?
103.
4,605.
Yeah. Oh, my bad. Bobby.
That's rounded.
So
to here.
be careful that you're not trying to jump through your steps and look for all the given information because, well, that was my mistake.
Yep.
Yeah, you
All right, let's do a couple cones before we have to get out of here.
Will you please make an Instagram? I'm just, please.
I'll think about it. I'll see how tempted I get. I'm climbing up on my roof this evening, so I gotta put up Christmas lights. The weather's nice.
Christmas, it's not even Thanksgiving.
Yeah, that could be my Instagram photo.
I have a question, Mr. Hudson. I have a very quick question. Can you give me something hippo related for Christmas?
What?
Can you give me a present that has something to do with hippos for Christmas?
No, I don't have any money, dude. I think. Okay, we're going to solve this cone. Cones are honestly easier than pyramids. Cones are honestly easier than pyramids. Here's why. The area of the base is easier to solve than breaking apart triangles and multiplying and everything else. So to find our base area here, they use blue, so I might as well use blue to match. So you got to remember your circle formulas. A couple of us are forgetting our circle formulas. And at least 2 people on the Chapter 8 test use the wrong formulas. Pi times the radius squared. 2 pi r is circumference. Discrepancy?
She's not agreeing with me.
Okay, well let's do this together, then we can see if we all agree. So, pi times my radius of 15 squared. 15 squared is?
225.
Yeah, 225. So this we might as well leave in pi for the current moment.
Well, it's in terms of pi anyways.
Exactly. But in general, I like to leave numbers in terms of pi until I have to switch it. Pi terms are just easier.
I got the other one.
Lateral area is pi times that same radius. Straddler?
Times 25 equals 375 pi.
We add those together and get a total surface area of
600 pies.
600 delicious pies. Squared. There's square pies too.
One pie.
I don't know.
Such a bad idea.
Yep.
That's pie that shape.
Dude, like.
One thing that I've never made is a pie. I've made pretty much everything else.
Hey, that's right. No, that's wrong. A 57.
What?
We got it wrong.
Oh, this or back up there?
Back up there, Max. It's wrong.
That's what I was saying.
This is what I get for not checking work. Hey, hold up. We got to check this work. Hold on. Hold on. We're not moving forward.
Ethan's right.
Oh, I was right.
52 number is right.
Hey, stop talking unless you're contributing to figure out where we made a mistake. We have students that have a discrepancy. We got to respect that and figure out, did we make a mistake? Max or Ethan, where does this come in? What did we do?
You just plug the numbers.
Oh, you mean just our calculation was wrong?
Two sets of parentheses, or two parentheses at the end.
So our values are right, just our calculation is wrong?
Right.
Yeah, because like I think you guys were squaring the root 3 and then multiplying it.
No,
with 18.
because the square root makes an open parentheses, so you have to, since you open another one, you have to close it twice. And if you only close it once, you get 1818. But it's not. It's
So you could also just do 18 squared times 3.
Well, yeah, you can't see that 18, and then they have
52 points.
root 3
Here,
squared.
For the
I'll have it
lateral
in a
area.
second. I'll have it in a second.
Yo, one person
No.
talk at a time.
For the
It's 52.3.
This right here, the 42 is not 42. So here's the way that you could have fixed this. Since we know when we go to square 18 root 3, that the root 3 squared is just going to be 3, just do 3 times your 18 squared. Then add that to 42 squared, then square root it, which gets you that this guy is actually 52.3. It's already in Smart, so then we got to change this guy. Might as well clone to 52.3. And when we change that calculation, our 4605 actually becomes, what do we get?
5648.4. That's hard to read.
Yeah, I'm confused. Why did you say there was something wrong?
We calculated
When, so, I don't have time to turn my document camera on. Here's what happened. There was a parenthesis issue in your calculator. When you typed in 18 radical 3, so go do this with me right now.
18 radical.
18 rad 3, and then you just hit squared. All you squared was the radical 3.
Yeah.
Oh.
You needed to put 18 radical 3, that value itself inside parentheses, before you hit the square. So it should look like this.
And
Like open parentheses 18, radical, open parentheses 3, close parentheses, 2 stacked, then squared.
Okay.
Thank you for pointing that out. I should calculate along with you guys. Or whoever found it. I mean, you had said 52 when we were calculating, but people said you were wrong. So, good work.
Good job.
I think we have a fairly good understanding of this. We'll pick up here on Monday and just make sure that you guys did okay on your practice. We are out of time. Because you guys spent so well. So I'm reminiscent of a high school teacher that I know. Like we knew we could get him off task, and some days you guys act like that with me, which is okay because we're moving really quickly. So I'll allow that.
No, we're talking about the 18
Okay.
times